Okay, cool. Okay, cool. 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 I'll be doing more of talking today. Next time when we meet, I would like we'll probably work on a project together, like an end-to-end machine learning project. And I won't be the only one here, and also like Mr. Dixon. I'm pretty excited to be here once again. So this is like my second time here. Last time I think it was Mr. Dixon that handled the breakout session with you guys. So yeah, let's just jump right into it. All right, so cluster analysis. Yeah. So this is going to be an interactive class. So I'll be asking questions. You don't have to feel uncomfortable. Like just respond. We're all here to learn. So yeah, does anyone have an idea what cluster is, or what does clustering mean? If you do, you can drop a comment, or you can unmute your mic and talk. I'm listening. I'm listening. Anyone? Okay. I guess I'll just have to. All right, cool, cool, nice. You can talk. I did.
Hello, can you hear me?
Yeah, I can.
Hello? Yeah, so like a cluster is like when you group like similar objects like into like a group where like their characteristics. Hello, I don't know if you can hear me.
I can hear you loud
Hello?
and clear.
Okay, yeah. So a cluster is like a group like where you actually put components or like observations or data points that are more similar in nature, like their features are more similar. So we used it to like to segment or maybe to discover patterns like across different groups and see how we can segment and classify our data into different components or different groups based on their similarities and yeah and their inherent structure. Yeah.
Oh, nice. Thank you very much for that. Yeah. So my next question is: do we use clustering for like supervised learning or unsupervised learning? If any other person can answer that, you can just unmute your mic and talk or drop a message.
Uh, Document or
All right. Good afternoon. Abdulakim.
we use clustering for unsupervised learning because clustering is like we have data that does not have labels, it's not labeled. We are trying to find
Yeah.
similarity data. That is why we use clustering so that we can find similarities. The model will find similarities.
Sorry, Abdulakim. Your microphone is kind of like cracking.
Okay.
Okay, look, but I get what you said. I think you said it already. Like use majorly in unsupervised learning because like they are unlabeled and we need to find like patterns around them, techniques to be able to label them. So we use one of those techniques called clustering, right? So there's something called clustering analysis. And what is clustering analysis? Clustering analysis is a technique for identifying groups in which the elements of each group are similar. And we use it in a different industry. We use it in different sectors of our areas of life or like stuff we do. Like we use it in businesses, we use it in pricing, we use it in production, we use it in uh, recruiting, like job seekers, like to identify who is best fit for a job. We also use it in operations management to know what department does better work, all those kind of a thing. So yeah, what is so in clustering is like a data mining technique also. It's used for data mining in machine learning. And data mining is basically the process of finding patterns, relationship, and trends to gain insights on large data sets. And clustering analysis is necessary because of the high dimension data we have. That is like most of the data we deal with, which are real life data, are always very large. And so because it's large, we need to break them down. And cluster analysis helps us to do that very well with feature selection and feature extractions. So let's go on to understanding cluster analysis. So cluster analysis, also known as clustering, is basically like clustering also. And which group similar data points form to form clusters. So it helps us to group similar data points to form clusters. And we also have like different type of cluster analysis. So I'm coming, I need to pop up something. So yeah, we have um we have centroid clustering, we have density clustering, we have distribution clustering, and we also have connectivity clustering. I'm going to go through each of these one by one for you guys to understand them. But before I go on, I just want to give a quick summary of all I've said about what cluster analysis is. So I said cluster analysis is basically clustering, and you guys are familiar with clustering. And clustering helps us to find patterns, relationship, to gain useful insight from large data sets because most of the real life data are actually high dimension data. That is, they are actually very large, so we need to break them down. And the data mining is a tool for clustering analysis. It's used as a data mining tool to break down data, like using feature extraction and feature selections. So yeah, let's go into the types of clustering. So we have centroid clustering. So centroid clustering, let me see if there's like a place I can use to just, okay, don't worry, I'm going to share my screen on hey, all right, so I'm currently sharing my screen. So I want to know if you guys can see my screen. Can you? All right. So let's jump right into it. So basically, let's look at this as like a graph, and let's look at this as like a graph. And in this graph, we have like different points, and each of these points have like so yeah, each of these points have like different sizes of circle. But at the end of the day, they are circles, right? Different sizes of circle and color of circle. So it has different sizes of circle and different colors of circles, but they are actually circles. right? And from here we can see that it's kind of like a cluster. They are similar, and this is just an example of clustering. Now, when it comes to centroids, in centroid we can have something like an X. Let me just explain this. Okay. We can have something like we can have something like an X here. This like an X here, and then another X here. Now, this X is basically a point, and this other X is also a point. And we can say this point is the centroid. Now, the centroid is basically like a center point, and that center point is where anything that is surrounding it is being clustered to is that is like, okay, you check, they are kind of similar, right? So we can just draw a line in between, saying that this and this are under the same cluster, and then this and this are under the same cluster, and then it kind of like give it like an optimal, what's it called? An optimal selection of the clustering, classifying one part of it to this particular centroid, and then classifying the other part to this particular centroid. Yeah, so that's how centroid works, basically. You select a particular centroid, and then you make sure it gets the optimal intersection. And this centroid, you can always iterate it. That is, you can always change how you want the centroid to be, like where you want the centroid to be. And changing the centroid is to make sure you are getting an optimal intersection, so that it gets the exact what's it called, exact item that should be clustered to its other item that are similar to it. So yeah, let's talk about the next one, which is density clustering. So for density clustering can be more, density clustering can be more like, we have like a lot of points or a lot of things that are actually very close to each other. And then you have another side where these ones like this are very close to each other. Now, for density clustering or like centroid clustering, there's no like a straight line intersection. The intersection can be different. It can be like maybe one part and then the other part. It can be like a circle, and this part too has its own side. It can even be like something like this, like a moon sign. So how do we normally determine like density clustering? Let's say we have like a point here. We can see that this place is connected to this place is connected to this place, and then like this, like this. So from here we can just see that, okay, these ones are actually under the same, like they have like similar properties, or they have similar sizes, or they are close to each other. So we can classify them under the same clustering. And then this one too, we can also classify them under the same clustering. This one is an example of density clustering. Now we also have another type of clustering called distribution clustering. So for distribution clustering, let's say we have a scatter plot like this. Let's say we have a scatter plot like this. It is kind of similar to centroid, but the difference is that, let's say now there's a point here in between. Let's put it as X. And then there's another point here in between as X. And then there's another one here in between as X. So the way the way we actually classify them under the same group is like looking at which one is close to X. And the proximity, that is like how close it is to X, determines if it will be under the same group. But the further it is away from X, means that it is not under the same group. So let's just say this one is under the same group. Let's just say this one is under the same group, this one is under the same group. And it's like something like this. I don't know why it's coloring it. Something like this. This is how distribution clustering looks like. So each of this, let's use this one here, for example. So this particular one here, from the middle of it, any item or any row that is close to the X is definitely under that group. But the further away it is, it means that it's not really like part of that group, but it's just clustered around it. It's like not really under it, but it's clustered around it. And then we have another type of clustering called connectivity clustering. You guys should give me a minute. All right, yeah. So for connectivity clustering, let's say we have a graph like this. Let me not use graph. Let me not use graph. I think the graph will make it clear later on, but I would use, let's say we have a class or we are in a class. This is the, let me know. Shall we? Let's start from the bottom. Okay, let me give you guys an example. We have fruit, right? We have fruit, and we want to classify this fruit because they are unlabeled. But then we want to connect them based on their similarities. And we know that we have different types of fruit, right? But in general, everything are fruit. So I would like you guys to mention like 6 fruits for me. Just mention 6 fruits for me. So we can work with that. So you guys can be able to understand connectivity clustering. So I need everyone to participate here. Like you can just put it in chat box for you. Oh, banana, okay. Okay, someone already mentioned banana, pawpaw. Okay. So we have banana, we have pawpaw. Okay. I need 4 more. We have orange. Okay. We have pineapple. Okay. I need 2 more. Yeah. Okay. What else again do we have? 1 more. Okay, apple. Cool. Okay, cool. Uh I'm going to ask I'm going to ask another question. Okay. So we have banana, we have orange, we have pear, we have apple, we have pineapple, and then we have okay, we have pineapple here. So this everything here are right, they are fruit. Now, mm, now we need to classify this fruit based on their similarity. For example, we can have some type of fruits that are okay, let's classify them based on vitamins. So let me just search online and ask Google what what Okay. Sorry, can you guys hear me? Please react if you can hear me. Because someone here said they can't hear me. Okay. Alex, you probably should go out and come back in. Maybe you'll be able to hear better. So yeah, let me search for banana based on all right, all right. Okay, so I found like a banana, comma, orange, comma, yeah, um, pineapple, what else? What else? Pineapple, purple, and apple. Okay. So yeah, so now from my research on Google, I found out that where is this? Okay, so for my research on Google, I found out that Apple, uh, I found out that Apple, orange, purple, and pineapple are under vitamin C, and banana is vitamin B, and apple is more of a fiber. So we can classify. So, okay, so we have orange, then we have purple, and then we have pineapple. They are under same the same vitamin, which is vitamin C. Vitamin C. And then we have banana in a different place, in a different classification, which is vitamin B. Let's just say VB. And then we have apple in a different classification. Apple and pear actually are classified together as fibers. So we can just put it as F. So now from here, we can see that they have been classified into different places. But then we can connect them together. We can say, okay, apple and um let me look for the one that will. Okay, let's just say apple, banana, or I'm looking for another classification I can put them on so we can connect them together. Mm, we're thinking together here. Uh, okay, let's just say apple and banana are closer to each other here, so we can connect them together, and then we can now connect this like this. So from here we can just say everything is fruit. We can just say this and this are close to each other, and then these ones are I've classified them as vitamin C. So from here we can just see that. Sorry about the whole like scattered stuff. I'll arrange it properly now. B. Can you guys see it? Please react if you can see it too. Okay. Hey, this. No. So from here we can see that this and this, I classify them under the same place because they are close to each other. And then the vitamin C just connects to everything all at once, and then it's just a fruit. So in your graph, it can be something like this. Let's just say PI, P, and O, they are together. And then we have P and A together. And then we have B on its own. But then we can now connect it together with this. And then everything are now on. Oh, shit. I guess I'll not close the circle. And then everything are connected together. So this is how like connectivity clustering looks like. Like this is how they are being classified. Uh Sorry about like not giving you guys a very good example, but you get the idea basically. So yeah, let me just give a quick recap. We talked about clustering analysis. I explained it, and then I talked about the types from centroid clustering, density clustering, distribution clustering, and also connectivity clustering. So yeah, I want to just go back to clustering itself or cluster analysis and explain a few things so that you guys can understand it better. So whenever you're working with a data and you have to do clustering, you can, work with it. So clustering basically, cluster analysis, we deal with variables most times. We try to check the variance of the variables. So, okay, sorry, guys. That wasn't, it. That wasn't, I lost my train of thought there. Okay, so we use clustering in companies to improve customers' experience. And let me give an example of that. An example of that is the way customer buys fruits and buys goods or products and consume them. what is their behavior with it. And it can be based on whether the customer likes healthy food or whether the customer likes healthy food but cannot afford buy healthy food. Whether the customer likes healthy food but only buys it when they have the money to buy it. That's three. Whether a customer likes healthy food but they they choose to only buy it if it is not expensive at all. So if you guys look at these examples I gave you, all of them likes healthy food, but the difference is that they don't. All of them have their factor which determines if they buy it or not, right? And this is just an example of clustering. And this is like an example of a real life way of clustering. So most times, these data they are similar, yes, but they have their differences. So we cluster them based on each of those factors. The ones that like healthy food and can afford it, the ones that like healthy food but cannot afford it, the ones that like healthy food and only buys it if it's cheap, the ones that like healthy food but only buys it when they have money. So like that's an example. So clustering is actually good for business in scaling. It helps to handle large volume of data. Like I already said, they have like high dimension data, which is like a lot. So they need to break them down. And then we have um, adaptability to different data type. They can they can use like any data type. They can adapt to any data type based on maybe categorical or numerical or date kind of data type. And then they also handle noise very well, and they handle missing data. Cluster analysis can be used to handle missing data. Um, yeah, clustering doesn't really have much under it. But another thing there is the practical part. I'm not going to touch the practical part at all. Like, you know, mm, I've actually like talked of most of what it is and the examples also. So let's move on. Let's move on to dimension reduction. Have any of you like do any of you have an idea of what dimension reduction is? Hello? Hello? Do any of you have an example of what dimension reduction is? Or have you heard dimension reduction? Are you guys still with me? Please, if you are with me, just react. Okay. 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 Do any of you guys have an idea of dimension reduction is? Okay, yeah, you can talk. I'm listening. Great.
Okay, so dimension reaction refers to reducing the number of features, or if we're looking at it from the angle of a data frame, reducing the number of columns that we have to work with to include just the columns that we need, the columns that give us the most information from our data without giving our model too much work to do, too much unnecessary work.
Okay. Yeah. Who else? Yeah, you're right. Who else? I need I need like responses. Who else? Yeah. Okay, yeah. Adedeji, you can go on.
Okay, so dimensionality reduction is like you are trying to select or reduce the features to the ones that probably capture the most variance, that the one that probably has the most to say about your data. So you maybe, for example, maybe you have 10 features and you know that about two of them really like are the ones that really capture the variance of your data, that explains your data the most. So the other would be redundant, like, or may not really add enough to analyzing your data. So you want to reduce them to like the ones that really capture, because if you reduce them, you know that okay, you would still likely have the same results. So it's it's very easy to visualize your model when you maybe are using like a data of lesser that dimension than maybe it's 9 dimensions. So you can reduce it to maybe two or three, and then you'll be able to see more patterns clearly than if you have too many features that do not really have much importance to your data. Thank you.
That's actually part. Yeah, so I will just go right into it also. So dimensionality reduction deals more with like variance, like Adedeji said, and it's basically variables and trying to check which variables have more variance. We have like so many types of data, and some of these data can be the same value from the first row to the last row, and it doesn't really have much help to the algorithm to help us predict our target value. And so we need to know how to handle this kind of variables. That's not the only kind of variable. We have variables that might not have uh, values at all in most places. And we also have variables that have different variance, but the variance are not much. Let's just say it can have just three variants, and those variants doesn't really add much to our algorithm or to the data itself. So we deal with dimension reduction using two things. We deal with it using first feature selection. Now, feature selection is basically like we selecting what features would help to um, be able to give us better value or predict our target values, right? And we do it using like filtering methods. Like we filter down, okay, what values here are missing. We check for missing values. We check for values that are highly correlated. We check for values that um, have the same variable and there's no much difference and all that. And yeah, that's like feature selection. And then we have feature extraction. Feature extraction is basically like um, taking the feature we currently have and creating new features. That's like you creating new features to be able to use it for your algorithm or for your machine learning uh, workflow. And sometimes we might not even have enough features. Like we can just have maybe just two features. For example, we can just have maybe just gender and names, and then we will need to add more features. Let's say we want to use this feature to determine if somebody would become without, I don't want to use sickness. Okay, would have heart disease or not. And then we are only giving their age, their names, their their height, their weight. But we are not giving body mass index, we are not giving all those other like features. Most times like it's either we create those features. Yeah, most times we will even need to create those features because the feature we have is not even enough. Since our target variable is to check if the person has additives or not. Now, it can be features, dimensional reduction can be in in um in oh, well, let's see. Okay, dimensionality reduction can be in what? Sorry, I lost my train of thought there. Uh, we use it in different types of data sets actually, like um regression. Yes, I just remembered. We can use it in regression or classification problem, basically, and it really helps us to get better accuracy, or like the results of our matrix becomes better. The more we do, the more we like extract features or select the best features. So I think I'm going to use an example from DataCamp. So I would share my screen from there because there is an example there that explains it. Okay, so yeah, let's start with the feature selection part. Try to open it up. Okay, okay. All right. Can you guys see my screen? Can you guys see my screen? Okay, cool. So yeah, we have this kind of data where we have city and prices, and from here we can see that this data is kind of fixed and it's overfitting from this graph. So basically, like it's because we don't have enough data yet. So we added more data, and instead of putting it as an absolute number, we added like float to give us, every data has like a normal distribution. So it gives us like a normal distribution, making it not to overfit anymore. So in this example here, they imported the data and they split the data into X and Y, where Y is the city. So what we are trying to predict there is the city, and then the rest of the data is like what we are using to predict it. So first off, we import our model selection, which is test train split, and then we split our data into a test size of 30% and um a train size of 70%. And from here, we use CSV to train it, support vector classification. We fit our data, and then we try to find the accuracy. And from here, we can see that the accuracy is 82, 0.82, which is like 82% basically. And from here, we can see that it's kind of okay. This one is actually okay. It's not, it's not overfitting more because the training data gave us 0.83%, and then test data is 82%. So yeah, we are trying to add features. So this is where I'm actually coming to. So the reason why we are trying to add features is to increase the accuracy of our metrics of the accuracy score. And then what feature was added? Now we want to buy a house. The only determination cannot just be the price. Imagine, like location of your space part, but what we want to use to determine is okay, what location do people buy houses from and what prices they have. So yeah, we have like 2.0, 3.1, blah blah blah. And then we have number of floors. The number of floors is basically a new what's it called? A new feature. So that's like we are selecting a feature, right? And then number of bedrooms and surface M2, forgetting what that was. But like these are other features that were created to be able to predict the city where people buy houses more. And yeah, so when we are trying to create feature or when we are trying to determine what feature we should use, there's something called variance threshold. Variance threshold helps us to get what features like add more meaning to our data set and helps us to get a better metric. Yeah, so this location is just selecting okay from what rule adds more to it. So it's removing a row that doesn't do anything to it here, which is just one row, by the way. And that one row have a very low variance. That is like the variance there, let's say we are just having 1 1 1 1 1 as its values from the beginning to the end. And so it found it, then removed it. And now the new variance currently is, so before we were having 74 uh, columns. But now we are having, 94 columns, but now we are having 93 columns. And that just shows that, okay, the remaining 93 columns have higher variance, basically. And then this box plot helps to check our variance, our variance, how much variance. So, so this is another data set, Botox data set, and the features it has is buttocks depth, buttocks pop details length, buttocks knee length, buttocks height, buttocks circumference. So these are the features basically. And from these features, we can see that we have a box in between, and then we have like this dot, like this T sign outside of the box. Now, whatever point is actually outside of the dot is called an outlier. So basically, like it's the variance is way ahead of the other variance, like it's not close to the main variance. And from here, we would need to try to normalize it because we're having outliers. We need to normalize to be able to make sure that those outliers are taken out and we don't get a data that is overfitting or underfitting. So we also use our variance threshold. So we also use our variance threshold. So there's something that determines the threshold we select, and what determines the threshold we select is calculating the variance. And to calculate the variance is basically the data set divided by the mean of the data set. And we'll be able to see the variance of the features of each features, and the variance is what we use to determine the threshold. So this is just a random threshold actually that is here, but we fit it by dividing the mean data set by the mean, and then we max it out. That is, how, let's say for example, yes, if you look at your screen, you can see the people on the call, and then you can see my screen, right? And then you can open chatbox and also see chatbox. What you are basically doing is you are maxing out, right? That is like you are trying to select a particular part of the screen you just want to see. And the part where I'm presenting is a maxed out part. The part where you guys are showing is another maxed out part. So yeah, that's basically what is also happening here. It's like looking at all these features and maxing out features that have variance that doesn't have too much outliers, and then bringing them together and using them as our main feature to be able to use for our data sets in our machine learning workflow. So the feature went from 93, the column, that is the features, went from 93 to 45 now. So we've maxed out about 50, maybe 50, I guess. No, we've maxed out about 48. Yes, that's it. Maxed out about 48 features, which means those other 48 features are not really adding much to the data set. So we removed it out. Now we have missing value selector. Now this one basically helps to check, okay, what missing values here doesn't really add much to the data set, or what kind of features they have missing values and they don't really add much to the features. So from here we can see that, okay, this one is having poison, 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 and then we have not available, not available, but then we have poison, poison, poison. As it's like, okay, the variance is not much and it's also having missing value. So we identify the ones with missing values, and to identify missing value is basically, so this is a new data set, which is like Pokemon data set, and Pokemon dot is any is basically like saying, okay, Pokemon dot is not available, which values there are not available, and then we can see that most of all of these are available except this two. So what we do is we try to check, okay, how many of that particular, let's try and check through our features, like through our data set, and looking at each features, which which ones have missing value. And from what we can see that, okay, names doesn't have any missing value, type 1 doesn't have any missing value, type 2 have a lot of missing value, 386. Total doesn't have any missing value, HP doesn't have any missing value, attack doesn't have any missing value, defense doesn't have any missing value. So what we try to do is, okay, we we take each of this and we try to check the like variance. Yes, these are these variants are calculated. The length of it divided by the sum of the ones that are not available. So from here we can see that, okay, 48%. This is basically 48% are missing from that. So this particular code here, Pokemon.df dot is na.sum divided by the length of the data set, is basically trying to check how many percentage of each features are not available. And then we realize that 48% of type 2 are not available. And 48% is quite a lot, so we would have to remove it. So from here, fewer than 30% missing value equals true value. So it's trying to check anyone that is less than 30%. That is, okay, we can have missing values, yes, and but we want to know if the missing values are no more than 30%. If it is more than 30%, then let's max it out. We don't need the ones with missing value that is more than 30%. So we just take it just shows us, okay, from here we can see name true, which means it's it adds fewer number of missing value less than 30%. Type also the same thing. Type 2 does not, because it has 14% of missing values. So yeah, what we try to do is we try to check threshold, applying a missing value threshold. So location here is just trying to select everything, but then not everything, the maxed out part. And from here, we know that the maxed out parts are basically the ones that are less than 30% of missing value. So what happens is that we just remove type 2. This is like a long way of removing missing values. But the reason why I would advise you guys should go for this is because if you use Pokemon DF.drop, because that also drops like a feature and like helps you remove feature. The drop as this one. What happens is it can be slower. In real life data sets, we can have a lot of features. We don't know how many features we can have, and we cannot be looking through it one by one. So instead of looking through it one by one, we just check the percentage of data that have missing value. So that percentage, you already have like your, what's it called, like a workflow you want to follow. Okay, you might say, I want to have a data set, a feature where um that does not have any what's it called, missing value that is less than I mean greater than let's say 40%. If it is greater than 40%, then we don't need the value, then it doesn't add any much value to our data set. So for us to easily remove it, we max it out. And to max out is pretty much easy from what we can see here. You just calculate it. You calculate what you need, and then you name the variable as max. So to be able to select the ones that you need, which is the max one, you just use your location LOC variable. LOC is basically location. They are trying to select, okay, what part do you want to select? Only the max part. And then you try to check if it has actually removed the ones that are more than 30%. This is they are more than 30%. And from what we can see here, it has. We have name, type 1, total, HP, attack, and defense. And then here we have blue bazaar. I don't know how to pronounce this. If any of you can help me out to pronounce, I wouldn't mind at all. Before I continue, I want to be sure like you guys are following up and you understand what I've been saying.
Yes, we are.
All right, cool. Uh yeah, so let me just move on. So yeah, we also try to check the correlation. Correlation is very important because sometimes there are some correlation that doesn't really help in determining our value. That is, we can have two features and those features are basically the same thing or they are almost the same thing. So if we're having two features that are basically doing the same thing, what happens is it gives room for overfitting. It gives room for overfitting. So to avoid overfitting or underfitting, we need to check correlation and we need to make sure that um, we don't have more than one features that are doing the same thing or giving the same result, kind of. So we pair them first, and this is the data sets we are using, ANSUR, and we are pairing them based on the gender, that is male or female, male or female. So correlation coefficient. So we have R minus one. R equals minus one means like they are negatively correlated to each other. R equals zero means they are correlated to each other like perfectly. And then R1 means they are positively correlated to each other. And then from here we can see that here we have R minus 0.88, which means that they are negatively correlated to each other. And we have R equals 0.05, which means they are kind of equally correlated to each other. And then we have R equals 0.86, which means they are positively correlated to each other. So correlation matrix can be represented in a table, and it just gives like a floating point number of from 0 to 1, or no, sorry, from, let's say, minus 999 to 1. Alright. Or minus 1 to 1. Sorry, it's minus 1 to 1 actually. Minus 1 to 1. So from here, we can see that this one here and this one here are the same correlation that is 1 to 1. And then we have this one here and this one here, and also the same correlation. And from this pattern, okay, this pattern is different completely. From this pattern, we notice that weight kg and height are correlated by 0.47%, 0.47, and then height kg and weight kg is also the same thing, which means if you are having the same value here, we also have the same value here. And then weight kg and weight in pounds are correlated by 1. And what does that mean? They are positively correlated. That's what it means. But then, like, they are perfectly correlated, which means weight kg and weight in kg and weight in pounds, yeah, might not really be necessary for our data, because we are basically getting the measurement of different size, and we're having two features basically saying the same thing. Like, okay, let's say I ask you now, what's your weight? You can either tell me your weight in kg, or you can tell me your weight in pounds. But at the end of the day, I'm knowing your weight, right? So I don't necessarily need your weight in kg and your weight in pounds. Is too correlated, and if data are too correlated, we don't necessarily. So what we need to do is move on. Yeah, before I move on, someone has a question. You can go on, man.
Okay, thank you, Fawaz. I want to ask this question because I might not be chance to ask it again when you are done explaining.
Okay.
You talked about some should I call them variables? Sorry, some features that maybe they are doing the same thing, so you remove them, or they are not connected at all. So I want to ask, how does that apply to multicollinearity, where two variables might not necessarily correlate individually, but together they actually give meaning? So how do we balance that? We don't go past that side. Thank you.
So how do we deal with those kind of values? To be honest, I'm not certain. I'm not certain, so I don't want to give you like wrong information, but I can actually research it now. So your question is basically in multicolonial values or like features. Why is it necessary that we need the two values to give it meaning for that particular feature? So yeah, I'm going to give you an example. Okay, yeah, I actually know the answer. And I think I did that last time I had the breakout session. So here's the answer. Unlike this example, let's say we have days in which you work, or the amount of time in which you work at a particular company. Now, the amount of time, some people can work for 7 days, some people work for 5 months, some people work for 5 years, but then everybody has worked in that place, and we need each of those particular data for us to get a better picture of what we are in our market. So what happens is we try to take all those data and then we classify it into one particular feature. So you personally can classify it into month, or you classify it into years, or you classify it into days. But whatever you are classifying it into, you are making sure that you only have one. You don't have, but you have already combined it together. So now we have 30 days in a month, sometimes 31, and then we have 12 months in a year. So logically, all you can notice there is, since we have 12 months in a year, we don't sometimes have 13 months in a year. So logically, we can see that we can classify it into months. And also, yes, we can classify it into years also. But we cannot do it in days or even, because it will give some issues. Our data might not be okay. So for your question with the multicoloniality, what happens is we need those data, because if we don't have them, then what we are basically saying is it is not available. Like, okay, let's say it is a missing value when it is not actually missing, and you can actually put a value there, even if that value is 0.001. So I want to know if you've gotten your answer.
Yes, I have. Thank you.
Okay. So unlike the features I gave you as an example now, in this feature we have weight in kg and weight in pounds. They are different. They are the same thing, because at the end of the day we are talking about the weight. But we don't need weight in pounds and weight in kg. You only need one of them. So we take just one. And if you can see, they are highly correlated to each other. That is why it is one. And positively correlated to each other. That's why it's one. So from here, we will notice that the feature that we really need here at the end of the day is height and weight in kg. And every other thing are kind of obsolete, because it will just make our data overfit. And that's why, if you notice, they painted it in red, and then these other ones were like in blue and green. Now, most time in correlation, they are always highly correlated to each other in a diagonal form. And the reason why it's like that is because they are the same thing. It's like saying weight in kg and weight in kg is the same thing. And then height and height, the same thing. And then weight in pounds and weight in pounds is the same thing. So it will give you one, which means they are positively correlated to each other. So in visualizing correlation, there are different ways of visualizing correlation. And this is just one way of it. You don't need to memorize this code, to be honest. All you just need to do is understand the visualization that you are getting. What does this visualization give you? And now from here, we can see that we have a line from here downwards to upwards. What this shows is that, okay, from this place, they are correlated, positively correlated. And then the top part is like positively correlated, but very much positively correlated. So anyone that is painted in like very dark blue means that we might not necessarily need that part. Like year and year, we don't need this weight in kg and weight in pounds. Like we only need one of it, like weight in kg, and that's all. So what we do is we max them out, and you can max them out using a feature in NumPy called tree, or TRIU, basically. So what it does is it takes the ones that are it takes just one side of it. That is like it takes year, from year to year. Can you guys see my cursor? It takes from year to year, and then leaves this part, because they are the same thing. You cannot be using everything. So you just want to view one side so you don't get confused. So it's just for visualization too. So this is the example. So we maxed out this part and we just left this part alone, because this is what we need, and that's all. So it just helps us to show the correlation that matters in our data set. So yeah, this is another example of visualization correlation. So we can see that this one is negatively correlated to each other. This one is positively correlated to each other. This one is very much positively correlated to each other. So we might not even necessarily need it. We might just need maybe, we might just need what's this? Super whatever is there. Honestly, I can't see. So yeah, let's go to the next part. Removing highly correlated value. So this place just helps us to visualize for this place just helps us to visualize correlated value. So now to remove it, another like different thing. So we try to first off we take the correlation as an absolute value. Absolute value, that is, we take it as a whole number, just a whole number, and that's all. and then we apply the maxing to it using our numpy. And our numpy helps us to visualize, but you can also help us. It basically helps us to max the necessary part, and then every other part are kind of obsolete. It doesn't see. So from here, if you notice, these ones are actually not missing values. It did not just show us the value because at the end of the day, this part will be equal to this part will be equal to this part, and this part will be equal to this part. This part like this will be equal to the same thing. And then here, this part like this, will be equal to 1, 1, 1, 1, 1. And then here will be equal to this part. So since you already know that's how it's going to be, you just took this part out and left us with this. Do you guys understand? Please react if you do. Okay. I love the fact that everyone is following me. I'll soon be done, and when I'm done, you guys can sign attendance. But I just chill. So yeah, what we are doing is we are looking through a list, and in that list we are checking for a threshold of 0.75%, and we are trying to remove anything that is more than that. So what I'm basically saying is we're trying to check the correlation values of each of these features and how they are correlated to each other. And anyone that we see that is higher than 0.95, we take it out. Because since it's higher than 0.95, what it means is that it's not adding much value to our data set. So we take it out. So we take it out by dropping it. And we can just create a variable that helps us take it out. And then we can see, okay, these are the ones we are taking out. Super whatever height, clavicle height, we take it out. And then we reduce our data. So here is it, feature selection. Feature selection helps us to just take out some of our data and leave us with only important, some of our features rather, and leave us with only important features. And then feature extractions helps us to create new features, that are ready for, that are necessary for our data set. And thankfully for Emmanuel, he asked a question that makes us to see why we need to create new features and why we need to remove features. So you guys should be able to understand that now. So here's just an example of a caveat. All these ones are just English, to be honest. So yeah, this one just there. Yeah, so we are done actually. So we are done with feature selection. We are done with it. Yeah, we are done. So yeah, for feature extraction, because I already said we're going to talk about feature selection and feature extraction. Uh, so feature extraction involves in creating new features by combining or transforming the original features. So new features retain most of the dataset information, but in fewer dimensions. And that's the example of the months, days, and years I gave you guys. So we are having too many dimensions here, and we need to just reduce that dimension into one. It's not like those data are not necessary. They are very much necessary to us, but we need to slim it down so we avoid overfitting or underfitting. So yeah, there are different methods of feature extraction, and one of those features is called PCA. That's like okay. Let's look at this one first. So yeah, imagine this is a feature. This one is just feature selection. What we do is we reduce the dimension by removing out features that are not necessary. And in feature extraction, we create new ones, which I have explained. So yeah, we are trying to break down a particular feature, a particular data set. So the data set talks about our body, so DF body, and in DF body we have width and we have height. So instead of using just width and height, we can weights and height are important to us, obviously, but we can add more features to help us determine whatever we want to determine, and which is IMB, body mass index, IMI, BMI. I don't know, I'm saying double. BMI. So BMI is gotten by dividing your weight by height and then raising it to the power of 2. That's basically what that does. And from here, we can see that we created a new feature, which is actually important to us because we don't have enough features to be able to use to predict whatever we want to predict. So we created a new feature which is called feature extraction. And this is just one of the examples of creating new features. No, you guys won't be able to get it in the Discord. You have to get it here because in the Discord now, anybody can just sign and only 17 people are currently here. So, yeah. I don't have the uh, link to the stuff yet. Well, let me just check. Let's just go on. Let's just go on. I'll probably you can just send me a message on Discord. I'll send it. Anybody that is here and might not be available later on, can just send message on Discord. I'll send you the link so you can sign for attendance. So you can manually create new features, which I've already shown you guys here. So this one, you are basically just removing features from here. So yeah, we can see that we have a particular feature here, which is left leg and right leg. And from here, we can see that some of them are actually like outliers. They are like way out of the stuff. So this place here is basically like trying to break it down, trying to check, okay, how the points that are here, because they are too large to find from 800 to 1000. So it brought it from 870 to 900. So most times we use, okay, let me know. So yeah, this is the way I was talking about of feature extraction, which is PCA. And what PCA does is it converts correlated variables into uncorrelated variables. PCA is principal component analysis, and it's reduced dimensionality, but it maintains the variance while reducing my dimensionality. And it just helps us to, get better features using our data set. So here we have our data set and we are trying to view it in a scatter plot. And what we are trying to view here is the variables that are correlated to each other, which is the arm's length and foot length. So we see that the arm length and foot length are very much correlated to each other. So we are trying to reduce the dimension. So what we do is we use PCA. Standard scalar, we try to normalize it. So we fit and transform the data, and then we add it into a new column basically. That's cold in my head. So you guys know about like normalization, and normalization is basically you selecting a particular. So we have different types. We have min-max normalization, we have standard scalar, we have some other ones too. So in here they are using standard scalar, and the way they are measuring it, okay, we are measuring from -2 to 2, and from here we can see that we have minus 2 to 2, and before it was like 240 to 300. So we broke it down so that we can be able to get a much smaller value for each of the rules, for each of that picture. So we don't have like too much large values. So it just helps us to standardize it. That's basically what's happening there. Uh, yeah, so I think I've mostly explained everything. So you can either extract your pictures using principal components, or you can do it manually. So this is the principal components part of it. So we import it from sklearn decomposition, and then we initialize it, I mean instantiate, initialize it, the same thing, and then we fit the data set, and we try to check for the variance, the ratio of the variance, and from here we can see that it has 90 and then 10% variance also, which means that there are a lot of variance there. So this is each of the variance for each of the data from 0 to the end. Some of them have very low variance, some of them have relatively high variance. Like this one have uh, low variance, this one have high variance, this one also have like very high variance. So yeah, I think we are done actually. So I would like you guys to ask any question if you have any. You guys can ask question now if you have any. I'm taking question now. So we talked about cluster analysis. This is basically cross clustering, and then we also talked about dimension reduction, or mostly dimension reduction. I said I was going to like talk about cluster analysis, practical parts later using a project. So yeah, for you guys to understand better. So do anybody here have a question? If you have a question, you can unmute your mic and talk, or you can drop it in the comment section, and or you can react if you don't have a question. Okay, you don't have any question. But I would like feedback. I would like to hear feedback from any of you. So yeah, what do you think about this breakout session? I want to get feedback from you guys. What do you think about this breakout session?
Yeah. Hi. Hi. Good evening.
Good
It's been
evening.
very informative. Like for me, hello. I've not really finished this course. I'm still on it, but because of it, some of the explanations were very vague, and I even went ahead to Google some things to understand better. But with your explanations, I think I'm able to have more context, and yeah, I really appreciate that. Thank you very much.
All right, all right. Thank you for your feedback, Adedeji. Anyone here has a feedback? And also, yes, I feel like this feedback is even much more important. What would I like? What parts do you feel like you have and we should cover for you instead of like just moving on, and maybe you're still behind and you want to cover. So I'd like to get your feedback on that. Okay, yeah, you can go on.
Yeah, thank you again. So me, I feel like it's one thing to actually like learn like on just like do exercises and like fill in the gaps on data camp, which actually really does well. But I feel like um that project,
It's
right? I
not
feel like
doing
maybe
justice.
if we can maybe yeah, like it's not really doing justice to okay, like you are cementing what you've learned to actually maybe put it in practice, right? Like all the tokenization, the PC and everything. So I'm feeling like maybe if we can maybe just have like an insight of maybe the project that I don't know if that project that we were supposed to do, if it's still in line, but if it's not, maybe we can just have like a tip or maybe something that we can even have beforehand and maybe we will submit at the end of the 6 months. So we can actually start to have insights so that what we are learning, we're actually looking at what we are learning and we're actually having maybe ideas on how to apply it to that project. So maybe towards the end of the program, we will now be able to apply all these things and actually start doing it. Because if the I think they said a task will be given to us. If it comes late, it feels like sometimes everything now there's now like overload of everything that you've known, and to apply it might now be more very
The
difficult. So
problem,
yeah,
right?
I just want to yeah. I just want to learn by applying actually. So
Yes, I feel you. I feel you. So here's the thing. You can see my screen, right? So I'm going to show you. You can see my screen, right? Please react. You can see my screen. React. Okay, cool. So you guys can actually do any project. Like literally do any project. All you just have to do is you come to the learn section and then you find this part where your menu bar where your my library dashboard assignments and all of that stuff is. You can do assessments. That is, you can check how good are you with, understanding these things. You can either do assessments with Python to like test yourself, or you can come to real world projects. There's also code along and there's also competition. So in this real world project, you select your track, which is like machine learning. So if you can see here now, we have clustering Antarctic penguin spreadsheet. We have uh, So yeah, we have predicting credit card approval. We have predictive modeling for agriculture. We have so many projects here. And honestly, like all you just have to do is you come here. See, we even have cleaning data with generative AI. This one is not our track, but you get what I'm saying. You can always come to this real life real world projects section. Pick any project you feel like you want to tackle it. You don't necessarily need to tackle projects in a day or even a week. Take your time. Use it to just practice what you've learned, right? And it's just like a sample data set you are using, but like on this place. That's one of the way you can go about it. Another way you can go about it is you can, I think I have to stop sharing my screen and share another one. You can, are you guys aware of this uh, site called Kaggle? All right, cool. You can always come to Kaggle, look for random data sets, and use that data set as your dummy data set to work on anything that you've learned. To work on anything that you've learned. So I feel like with all of this, like you should be good. That's one tip. That is one tip. But the most important tip I want to give you here is this. During my own like time of learning and everything, I didn't use DataCamp. That's why if you notice like some of the stuff they are not even take. I didn't use DataCamp to learn machine learning. But the way I learned was by actively learning. There's a difference between passively learning and actively learning. Okay, I'll type the sites in the comment section. In the message box. Okay, let me go on. So there's a difference between actively learning and passively learning. A lot of times, like we passively learn because we are distracted or we are multitasking. But when you want to learn, I advise that you just focus on whatever you are learning. And what happens is you are consuming with what's it called? You are deliberately consuming the content. And because you are deliberately consuming the content, you want to really understand it, which means you do research on your own. You go on Google, you go on Gemini, you go on ChatGPT, wherever you go on to understand better. Write down if you're not good with like, taking things in your head all at once. You write it down, you always go back to it and check it. And there's no crime in not knowing something. I swear. Even me, from the way I'm even teaching, you guys can see that some of the things here we're just going one way, another way sometimes. Like, but one thing you should know is you learn better from your mistakes. And I feel like that's even the best way to learn from your mistakes. And if you can make more mistakes, I encourage mistakes because if you are, that's the way you can learn better and understand better. And it doesn't matter if you are slow about it, but as long as you are learning by 1% every day, I feel like you are good. So yeah, like that's what I have to say about it. So I guess I have answered your question and stuff. All right. Yeah, for the link, you guys should chill. Oh. Let's just chill for the link. Let me try and get. Let me try and get. For um, I guess we have to get the link before we leave. It's almost time. I'm actually asking for it, but like nobody is replying. So, or or don't worry, I'll just I'll create a new. Okay, so I just created a new like uh Google Forms. So you guys just use this as your attendance. You can check the message box, click the link there and like take your please if you are done, you can just leave when you are done with taking the attendance. you guys should sign attendance, so like sign up and leave so I can. Hello, Alex, sign your attendance, so that you can